Today, thanks to the quick advancements in science, technology, and material science, as well as the use of advanced manufacturing techniques, the production of industrial girth gears has reached a new level. SEW segmented ADI girth gear is designed and manufactured according to the applications of customers, non-standard customization. Customers receive the greatest experience with ADI girth gear products that SEW has tailored for them. The SEW segmented ADI girth gear provides clear advantages over the standard girth gear in halves. One segment model is all that is required for casting the SEW segmented ADI girth gear, which offers appropriate segmentation, high casting quality, and reduced pattern costs. Because of its tiny size, the segment can be processed in a machining center. Higher strength and superior overall qualities are fostered by the ADI isothermal quenching heat treatment procedure. The SEW segmented ADI girth gear segments each have a practical design, precise and manageable size, and are interchangeable, making installation and adjustment simple. The cost of maintenance is significantly reduced when only the locally damaged segment needs to be replaced. The shipment of SEW segmented ADI girth gear is therefore more practical and economical. The finite element method, FEM, simulation program also optimizes the SEW segmented ADI girth gear. The distribution of stresses, deformation, bolt connection dependability, and joint gap of the gear segment can all be discovered through analysis. Diverse girth gear types have been introduced by SEW segmented ADI girth gear to meet the needs of various working environments. Concerning the spring plate connected segmented girth gear for hot kiln drum, the gear segment is mounted on the drum with the spring plate to counteract the effect of the drum's thermal expansion, ensuring that the girth gear consistently maintains its original installation position throughout operation. At room temperature, the segmented girth gear for the drum is installed on the drum using a mounting flange or welding flange. The segmented girth gear that is attached to a welding flange is mostly appropriate for drums without mounting flanges or for projects involving replacement and reconstruction. Most operating situations can be met by spur girth gears in their standard configuration. The helical girth gear, which is frequently used in large mining mills, has a better contact ratio and load transfer capability than the spur girth gear. The gear segments section can be split into two types: T-shaped single spoke plate and Y-shaped double spoke plates. The T-section type of gear segment is ideal for medium load mills, and the Y-section type has higher structural stability for heavy-duty mills. Two types of arrangements for pinions that drive the SEW segmented ADI girth gear are available. One is to directly install the pinion on the output shaft of the gear unit. The other arrangement is a pinion setup with extra bearing seats. The pinion shaft is supported by two independent bearing seats that take the load of the meshing force between the girth gear and the pinion. The majority of other girth gear products currently available on the market are made of cast steel, but the SEW segmented ADI girth gear is made of Austemper ductile iron, ADI, an alloy that has undergone a process called isothermal quenching heat treatment procedure to produce a metallographic structure matrix made of austenitic ferrite, austenite plus ferrite, and spheroidal graphite. The tensile strength, yield strength, hardness, and other mechanical properties of ADI material are superior to those of high-grade ductile iron and cast steel, while its density is lower than that of cast steel. It also boasts exceptional properties. ADI is currently a widely used material. The tooth flank contact fatigue strength of ADI material, which is better than that of high-grade ductile iron and cast steel, is one of its best qualities. High-grade ductile iron has a lower tooth root bending fatigue strength than ADI material, which is equal to cast steel in this regard. Due to its unique structure, ADI material has an extraordinarily high wear resistance that is higher than that of high-grade ductile iron and cast steel. Its technical requirements may be following a variety of norms, including ISO, EN, and AGMA, American Gear Manufacturers Association. The material of SEW segmented ADI girth gear has unmatched quality benefits as compared to other brands. Our customized machining center integrates the functions of horizontal machining, vertical machining, and independent gear tooth milling, and then complete all machining procedures, including gear tooth milling, the joint surface milling of the gear segment, the positioning pinhole and connecting hole drilling of the joint surface, and the mounting surface milling of the drum mounting flange. Each gear segment of the same model can have good interchangeability thanks to sophisticated tools and highly accurate probes. The machining precision of the SEW segmented ADI girth gear is exceptionally good, and each segment's machining accuracy is higher than level 8 in ISO or level 9 in AGMA. Low-level vibration of the girth gear during operation is guaranteed by high-precision machining, which provides the girth gear's dependability and stability. Every segmented ADI girth gear manufactured by SEW is put through a series of rigorous expert inspections from start to finish. After the product has been finished, the inspection engineer will follow the inspection plan to proceed the 3D coordinate measuring and teeth measuring of gear segment to verify that the joint size and teeth characteristics comply with the requirements of the designs and assembly. This will assure the product's quality. After all the gear segments have been processed, they will be assembled and measured in the factory assembly area, which will ensure the accuracy of the overall size. The independent development platform for girth gear assembly and inspection supports online detection of parameters such as tooth flank contact, backlash, radial and axial runout of girth gear, and can carry out rolling experiments of girth gears and pinions in the factory. SEW segmented ADI girth gears are widely utilized in significant industrial and mining businesses all over the world, providing consumers with a high quality and effective experience. With the use of cutting-edge R&D technology and strong capabilities, SEW create and develop more sophisticated goods and offer users individualized services in the future. The users in SEW will work together to build a better future